Picture the deadliest weapon of the 21st century. What do you see? A multi-billion-dollar stealth jet or a hypersonic missile tearing through the clouds? Think again. Death now arrives with a slow, buzzing sound, and it costs less than your family car. This is the Shahed-136. Behind this simple triangular shape hides a technological irony. Its mechanical heart isn't a mini nuclear reactor or a sophisticated jet turbine, but something you might find in your shed, a modified lawnmower engine. Welcome to the new era of asymmetric warfare. I'm Ethan Walker, and you're watching Weapons Science. Today, we aren't just looking at a drone. We're dissecting a military revolution. We'll strip down the MD-550 engine to understand how low-end tech is dismantling billion-dollar defense systems. Modern air defense systems like Iron Dome or Patriot are designed to intercept supersonic jets. But what if the enemy flies low, slow, and so cheaply that shooting them down actually bankrupts you? This is the mathematics of ruin. The Shahed-136 is the primary variable. In the next 30 minutes, we'll analyze its heat signature, dissect its composite wood material, and calculate its attrition cost. We'll see how this 50 horsepower engine rewrites global conflict rules. To understand this monster, we must look at its lineage. This engine isn't a new invention. Its DNA traces back to German light aircraft designs. What we see is the dark evolution of civilian aviation into loitering munitions. This is the Mado MD-550, a 4-cylinder, 2-stroke air-cooled piston engine. No advanced fuel injection, no complex military ECU. This is the definition of mechanical brute force, simple, rough, but brutally effective. Think of your car engine. It has thousands of moving parts. The MD-550 ditches all that for simplicity. No complex valves, no high-pressure lubrication. Fuel is mixed directly with oil, just like your lawnmower. Why is this genius in a sinister context? Fewer moving parts mean fewer things to break in dusty, dirty battlefields. Sophistication is often a weakness. The MD-550 is the AK-47 of the aero engine world noisy, but it keeps running. Weighing just 16 kilograms, this engine produces 50 horsepower. This power-to-weight ratio is crucial. It allows the drone to carry a 50 kilograms warhead over 1,000 kilometers. It is terrifyingly efficient. Let's talk money. This engine costs between $2,000 and $3,000 to produce. Compare that to the small turbofan in a cruise missile costing millions. You can build 50 MD-550s for the price of one turbine engine. Because it uses civilian technology, the supply chain is nearly impossible to break. Parts can be bought globally as hobbyist components. International sanctions struggle to stop the flow of items that look like motor scooter parts. One of the most horrifying features of the Shahed-136 is its sound. People in conflict zones call it a moped or flying scooter. The low-frequency buzz isn't a coincidence, it's a design byproduct. Psychologically, this sound is terror. It announces its arrival, allowing fear to grow before the explosion. Unlike supersonic missiles that arrive without warning, the Shahed creates a psychological siege. For military sensors, this sound is confusing. Acoustic detection systems often filter out civilian background noise. It sounds like a food delivery bike or a chainsaw, making it ignored by algorithms hunting for jets. Observe the engine position. It's at the very back in a pusher configuration. This isn't aesthetic. By putting the propeller at the rear, the front sensors and warhead get a clear, unobstructed view. This configuration also hides the heat signature. Seen from the front, the hot engine is masked by the airframe. For heat-seeking missiles, the drone is almost invisible. Since it's air-cooled without a liquid radiator, it saves massive weight. It trades high-altitude performance for simplicity. Once again, simplicity defeats peak performance. The main problem with cheap two-stroke engines is vibration. It can shatter sensitive electronics. How does the Shahed solve this? Standard industrial rubber mounts and epoxy glue. The fuel system is just as primitive. No self-sealing tanks, it's often just plastic storage. It's a fire risk. But remember, this drone is a kamikaze. It's designed to detonate on impact anyway. Moving to the frame, if a fighter jet is titanium and carbon fiber, the Shahed is closer to your kitchen cupboard. The structure uses honeycomb technology sandwiched by cheap carbon fiber or fiberglass. Even internal components often use plywood. Why? Because wood is transparent to radar waves. To a defense radar, a flying piece of wood is harder to detect than metal. We call this radar cross-section, or RCS. Due to the delta wing shape and non-metallic materials, the RCS is tiny. On a radar screen, it might look like a large bird. The tailless delta wing provides massive lift with minimal drag. It's incredibly stable, allowing for long-distance straight flight without complex control inputs. But it has a weakness: poor initial acceleration. It can't take off from a short runway. The solution? Simple rocket boosters on a truck-mounted rack. No airbase needed, no concrete runway. They can launch 5 drones at once from the side of a highway and disappear before the smoke fades. Now, the brains. Don't imagine a supercomputer. The Shahed uses commercial off-the-shelf components. The same processor might be in your smart washing machine or an old game console. Navigation relies on civilian GNSS, GPS, GLONASS, and Beidou. The receiver is a cheap ceramic antenna you could buy online. It knows where it is, but it's blind to its surroundings. Critics say, just jam the GPS signal. But newer versions have CRPA antennas' small discs that intelligently block jamming signals from the ground while listening to satellites above. If GPS dies, it switches to inertial navigation. Imagine walking blindfolded while counting your steps. It's not perfectly accurate, but enough to keep the drone flying straight. Most Shaheds don't have cameras or laser trackers. They can't chase moving targets. They strike pre-programmed geographic coordinates, buildings, power grids, or oil depots. This is the attrition math. A Patriot missile can cost $4 million. One Shahed is maybe $50,000. If you have 8 missiles and 20 drones arrive, you lose. Even if you shoot them all down, you've spent $30 million to stop a $500,000 threat. Any nation's defense economy will bleed. This is why we see a return to World War II-style anti-aircraft guns. What's next? Radar-absorbing black paint for night attacks, mini-jet engines for speed, and 4G, 5G integration for real-time communication. The future is AI. Imagine if this drone weren't blind. With a cheap camera and AI chip, it could recognize tanks or radar sites and choose its own targets autonomously. The era of superpower air monopoly is over. The Shahed-136 teaches us a hard lesson. Sophistication doesn't always mean victory. In a war of attrition, quantity has a quality all its own. Goliath is being outpaced by David's low-cost tools. Thanks for exploring with weapon science. If this analysis opened your eyes, hit like and subscribe. How should future defenses counter these threats? Let me know in the comments. See you in the next tech breakdown. Let's look closer at the piston. The aluminum casting is rough, showing metal porosity. But for a flight that only happens once, long-term durability is irrelevant. This is disposable engineering. The carburetor system is also fascinating. Instead of complex injection, it uses a simple diaphragm carburetor. It's 1950s tech, but it's immune to EMPs that could fry modern systems. The wooden propeller is laminated for strength, optimized for cruising, not speed. Its low RPM contributes to fuel efficiency, enabling hours of flight time. Powering the electronics is a small alternator on the crankshaft. It generates electricity as long as the engine spins. Simple, self-contained, no heavy, fire-prone lithium batteries needed. Wing controls are standard hobby servos. You can buy these at toy stores. They are strong, cheap, and replaceable. Field technicians can swap 1 in 5 minutes. The modular wing design means these drones pack flat. A standard shipping container holds hundreds. It's an IKEA nightmare for intelligence agencies trying to track shipments. They call it the IKEA effect. No aeronautical engineers needed, just soldiers with a wrench. The logistics of munitions will never be the same. Warheads vary. For personnel or radar, they use fragmentation sleeves. For tanks, a shape charge can be fitted, focusing energy into a molten metal plasma jet. The trigger is a simple mechanical contact. No complex laser sensors, it explodes on impact. Again, simplicity reduces the chance of malfunction. We're halfway through. Good enough is the enemy of perfect. The Shahed isn't trying to be perfect, it's trying to be cheap enough to overwhelm. How to stop them? Electronic warfare, flooding GPS frequencies with noise. But as we discussed, anti-jamming antennas are getting cheaper, and drones use waypoints to avoid zones. Future defenses might be lasers. A few dollars in electricity to heat the wing until it burns. But lasers are defeated by fog, rain, and clouds. Shaheds often fly in bad weather. Drone hunting drones? Faster drones that fire nets at the propellers. A physical solution for a physical problem, minimizing collateral damage in civilian areas. The success of the Shahed has changed diplomacy. Nations once considered irrelevant in the military industry are now strategic exporters. It's the new currency of international politics. We can't ignore the terror aspect. Attacking energy grids in winter isn't a military tactic. It's designed to break civilian morale. Accuracy has improved to within a few meters. Reports suggest engines are modified in the field, changing fuel mixtures for more power or explosive effect. Compare this to the complex backpack-sized American switchblades. The rocket booster uses simple propellant like industrial-scale fireworks. Basic chemistry, no cryogenic fuel needed. It's about accessibility, not peak performance. Cables lack military-grade shielding. They use standard automotive wires. This makes them vulnerable to near-field interference but keeps production costs incredibly low. Some variants use composite plastic propellers, more weather-resistant and easier to mass-produce. The evolution of materials continues as supply chains shift. The lack of a data link is a feature, not a bug. It means the drone doesn't emit radio signals that can be traced to the launch site. It's electronically silent. Ukraine formed mobile fire groups, small teams with pickups and searchlights. This is manual defense against automated threats. Technology meeting human instinct. VR simulators now train soldiers to lead shots for objects moving at 180 kilometers per hour. It requires specialized skill. The human factor is still vital in this war. Decoy drones are now launched filled with foam instead of warheads to bait defenses into wasting expensive missiles. It's a game of economic attrition. Experiments with radar-absorbing paint are frequent. Not F-35 level, but enough to reduce detection range by kilometers, cutting reaction time for defenders. Efforts to modulate exhaust sounds are underway to confuse acoustic sensors. Audio camouflage. The war of sensors is just as intense as the kinetic one. Rumors of Wankel rotary engine experiments exist. Smoother vibration, higher power to weight. Despite being fuel-hungry, it's easier to produce in some regions. Chips are often smuggled through third countries. A GPS chip made in the West goes to Asia, then to the Middle East, before ending up in a drone. Digital footprints are erased. Pop-up factories and trucks could 3D print fuselages locally. The logistics of ammunition will never be the same. Ammunition is becoming a local, on-demand product. When killing becomes this cheap and automated, does the threshold for war drop? The Shahed lowers the entry cost for strategic air power. It changes the moral calculus of conflict. Signal intelligence tracks satellite communication before launch. It's the only moment the drone speaks to the world to download coordinates. A fleeting digital heartbeat. Pusher propellers often shatter on impact, making reverse engineering difficult. The key aerodynamic parts are lost. It's a design feature for obfuscation. Backup batteries allow for a final glide if the engine fails. The drone glides to the target using remaining control authority. It's a terminal mode that's silent and deadly. The secret recipe? Motorbike engine, plywood body, GPS chip, and iron warhead. Mix with saturation math, and you get a strategic weapon. Clone variants are appearing in other conflicts. Different names, different paint, same DNA. This Pandora's box is wide open. Winning this war requires lowering defense costs. Microwaves, kinetic weapons, lasers. We cannot keep firing Ferraris at motorcycles. OSINT analysts track serial numbers on engine debris to find factories. It's a digital detective game, uncovering the global supply chain behind every flight. Bolts are often welded to prevent loosening from vibration. Zero maintenance because it isn't meant to last. A testament to disposable design. Swarm intelligence is the next terrifying step. Drones communicating, maneuvering to avoid fire, sharing tasks. One scouts, the others strike. Maybe hybrid electric engines for a silent approach, gas for the long haul. Combining MD 550 range with the stealth of an electric motor. The Shahed has erased the concept of a safe rear line. Cities 2,000 kilometers away are now targets. Every civilian with a smartphone is now a radar node. The MD 550 will be remembered not for greatness, but for impact. Like the AK-47, it democratized destruction. We've seen the pistons, the wood, the logic. Innovation comes from unexpected places. The most dangerous technology is often old tech used in a new way. Understanding this is vital for a stable future. Stay curious, stay critical. I'm Ethan Walker. See you next time.